Welcome to this lesson on Kotlin best practices. Today, we're exploring one of the most important principles in Kotlin programming, immutability. Specifically, we'll learn why you should prefer val over var when declaring variables. Understanding this concept will help you write safer, more maintainable code. Immutability means that once a variable is assigned a value, that value cannot be changed. This simple practice has profound benefits for code quality. And by the end of this video, you'll understand exactly why Kotlin encourages this approach. Let's start with the fundamentals. In Kotlin, there are two keywords for declaring variables, val and var. The keyword val creates a read-only variable with an immutable reference. Once you assign a value to a val variable, you cannot reassign it to a different value. For example, val name equals Kotlin creates a variable that will always reference the string Kotlin. On the other hand, var creates a mutable variable that can be reassigned. For instance, var count equals 0 can later be changed to a different number. The key difference is that val enforces immutability at compile time, while var allows flexibility to change values throughout your program's execution. So why should you prefer val over var? There are 4 major benefits. First, code with val is easier to reason about. When you see a val declaration, you immediately know that the value won't change, reducing mental complexity. Second, it reduces cognitive load when reading code. You don't need to track how a variable might change throughout the program, making code comprehension much simpler. Third, it prevents accidental reassignment bugs. The compiler will catch any attempt to modify a val variable, stopping errors before they happen. Fourth, val variables are thread-safe by default. Since the reference cannot change, multiple threads can safely read the value without synchronization, eliminating entire categories of concurrency bugs. Let's look at a concrete example of problems that can occur with var. Imagine you declare var username equals Alice . You then call a function called processUser with username. Later in your code, you accidentally reassign username to Bob . Now when you call sendEmail with username, you're sending the email to the wrong user. This type of bug is surprisingly common in real-world applications. The variable was changed unintentionally, perhaps by a team member who didn't realize it was still being used, or perhaps in a refactoring that went wrong. These bugs can be difficult to track down because the reassignment might happen far from where the incorrect value is actually used. Now let's see how val solves this problem. When you declare val username equals Alice , the variable cannot be reassigned. If you try to write username equals Bob , the Kotlin compiler will immediately give you a compilation error. This means the bug we saw earlier is caught before your program even runs. The sendEmail function will always receive the correct user, making the code safe and predictable. This compile time safety is one of Kotlin's greatest strengths. The compiler becomes your ally, preventing entire classes of bugs from ever reaching production. You get immediate feedback during development, not runtime crashes or incorrect behavior in production. One of the most powerful benefits of val is its relationship with thread safety. When you use val, the reference cannot be reassigned, which eliminates race conditions related to variable reassignment. In concurrent programming, race conditions occur when multiple threads try to modify the same data simultaneously, leading to unpredictable results. With var, you need synchronization mechanisms like locks to ensure thread safety, adding complexity and potential performance overhead. However, with val, the reference is safe to share across threads without any locks or synchronization. Multiple threads can read the value simultaneously without any risk of seeing inconsistent or corrupted data. This makes concurrent code simpler, safer, and often more efficient. While we strongly prefer val, there are legitimate cases where var is necessary. You should use var when accumulating values in loops or performing calculations where a value genuinely needs to change over time. For example, computing a sum or building a result incrementally. You also need var for state that genuinely changes during program execution, such as tracking user interface state or game state. Finally, counters and iterators in algorithms often require mutable variables. The key principle is this: Use var only when you have a clear, specific reason for mutability. If a variable's value doesn't need to change, always use val. Don't use var simply out of habit or because you think you might need to change it later. Here's the golden rule for Kotlin development. Always declare variables with val by default. This should be your starting point for every variable declaration. Only switch to var when you have a clear, specific reason that the variable needs to be mutable. This approach is called "immutable" by default, and it's a cornerstone of good Kotlin style. When you follow this practice, your code becomes more predictable, easier to understand, and less prone to bugs. The compiler helps enforce correctness, and your code naturally becomes more thread-safe. Remember, immutability is not a restriction, it's a feature that makes your code better. Start with val and only use var when mutability is truly required.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.